As the question says, a block of mass m is kept over another block of mass capital M, and the system rests on a horizontal surface. A constant horizontal force F acting on the lower block produces an acceleration F by 2 m plus m in the system. The two blocks always move together. Now A part is find the coefficient of kinetic friction between the bigger block and the horizontal surface, that is this surface, and B, find the frictional force appearing or acting on the smaller block, that is over this block, and the C part being find the work done by the force of friction on the smaller block, that is work done by the bigger block during a displacement d of the system. Now what is happening in this question is that this force is being applied to the bigger block, which is actually trying to pull this block, the bigger block. But there is some friction existing between this surface and the block, which is actually opposing the relative motion between this. So it is acting such that it is prevented from moving. Also, there is some friction between this smaller block and the larger block. So what's happening is this block is moving ahead only due to the presence of friction. That means that only friction is responsible to bring this small m into motion. Right? So, proceeding ahead with the question, we have been given the acceleration being force upon 2 m plus m, and if we draw the free body diagrams, then we can show the bigger block as having the force F in the right, the friction F1 on the left, and the friction F2 on the left with an acceleration A ahead. If we do the same thing for the smaller block, we can say that here we are having an acceleration A along with the friction F1 here. So, also we can say that if we take the normal reaction here to be N1 and normal reaction on the bigger block to be N2. So I can say that N1 is equals to mg, right? And also the frictional force, that is F1 equals to mass into acceleration. Now what is frictional force? This is mu times the normal reaction, that is mg. So it is mu mg equals to ma. Cancelling the factor of m, we get mu being a over g. And the acceleration has been given us in the question, giving us the answer for this problem as this, right? Now this was the first part of this question, and now proceeding with the second part of this question, in which we need to find the frictional force acting on the smaller block. Now what is the frictional force? This is simply mu n1, that is mu which we found out in the first part itself, like this one, and the normal reaction N1 that has been given as, rather we found out in the first part as mg. Putting it over here, cancelling the factor of g, so giving us mf over twice of m plus m, right? Now, proceeding with the C part of this question, that is the third part, which is find the work done by the force of friction on the smaller block by the bigger block during the displacement d of the system. Now we all know that the work done equals to force into displacement s in the direction of this force. This is not cross, this is simply the multiplication, okay? Don't misunderstand it as the cross product, right? Because it is actually the dot product. Here the displacement is d that has been given in the question itself. here. So putting it here, we can get it as the force, which is the frictional force that we found out in the second part, as mf over twice of m plus m, and the distance that has been given as d, giving us the total work done by the frictional force.